All right, listeners, buckle up because today we're tackling a question that's fascinated people forever. Can we bottle lightning?
Yeah, it's
We're going to dig into some incredible excerpts from Can We Bottle Lightning? The Quest to Harness Nature's Power.
really interesting stuff.
We'll unpack the science behind it, the challenges, and the surprising directions this whole quest is taking us.
You know, it's easy to see why lightning has always captured our imaginations. I mean, think about it. A single bolt can contain 1 billion joules of energy.
Whoa, 1 billion. That's like
That's enough to power a typical home for, get this, a whole month.
a whole month from just one bolt. That's kind of mind-blowing. It makes you wonder why we haven't figured out how to use this stuff already.
Right. You'd think it'd be as easy as, I don't know, sticking a giant battery in a thunderstorm. But
Right.
unfortunately, it's not that simple.
So why is that?
To understand why, we need to get down to the basics of how lightning actually forms.
Okay, let's break it down.
It all starts with charge imbalances that build up in thunderclouds. Think of these clouds as enormous, chaotic spaces, just churning with ice particles and water droplets.
I like the imagery.
These particles are constantly bumping into each other, right, and getting tossed around by super strong winds.
And that creates...
Static electricity on a massive scale.
Okay.
Eventually, the difference in electrical charges between the cloud and the ground, or even between different parts of the cloud, gets so huge, so out of whack.
Like a breaking point.
Exactly. The air itself can't handle it anymore, and it breaks down. That breakdown, that's what we see as a lightning bolt. This incredibly sudden, powerful release of energy, all trying to even out those charges.
So like a super-sized static shock. But like way bigger than anything we ever experienced.
You got it. It's this amazing display of nature's raw power, but it's also incredibly short-lived and unpredictable.
And that's where things get tricky when we talk about harnessing it.
Yeah, that's the biggest hurdle.
So is bottling lightning really just a fantasy? Or is there any way to actually capture this incredible force?
Well, when we say bottling, it's probably not what you picture. Literally capturing a bolt.
Right, like in a jar or something.
Not quite. It's just not practical. It's like trying to catch a bullet in a teacup. The speed and intensity of that discharge are just mind-boggling.
I can imagine.
We're talking billions of volts of electricity all surging through the air in a fraction of a second. Anything we try to use to capture it would probably just get vaporized.
Yeah, good point. But I bet people have still tried, haven't they?
Oh, absolutely. Some researchers have experimented with giant capacitors. These are essentially devices that can store electrical energy.
So using them to try and snag some of that energy from a lightning strike.
Exactly. But even these attempts have only managed to capture a tiny, tiny bit of the total energy released.
So not very efficient.
Not at all, and honestly, pretty risky too.
So even if we could figure out how to hold on to it, we're not getting much out of it.
That's the thing. It all seems a bit like a losing battle.
It does. So why, if it's so impractical and even dangerous, do scientists keep trying to harness lightning's power? What's the appeal?
Well, that's the big question. See, lightning, as crazy as it is, it's also the ultimate renewable energy source. It's clean, it's abundant, and it's, at least in theory, readily available.
Okay, I'm starting to see the attraction.
But there's a catch. Even if we could capture a bolt perfectly, there's the issue of scale. One bolt might power a house for a month, but imagine trying to power a whole city.
That'd take, what, thousands of bolts?
At least, maybe millions. And the biggest problem, we can't control when and where lightning decides to strike.
So relying on it to power our homes is a bit of a long shot.
Yeah, at this point, it's more about the what if than a practical solution. What if we could crack the code? What if we could tap into this incredible force of nature?
The possibilities are pretty exciting, even if it's just a what if for now.
Exactly. There's something powerful about that what if. And who knows what the future holds. But even if we never manage to actually bottle lightning, just trying to understand it, trying to control it, it's pushing the boundaries of what we know.
It's like, even if we don't achieve the goal we set out with, the journey itself can lead us to amazing places.
I like that. It's like climbing a mountain.
Yeah.
You might not reach the summit, but the view from the slopes can be breathtaking.
Mm-hmm.
And with lightning, those views are leading us to some incredible new paths for harnessing energy and really understanding the world around us.
I love that metaphor. So if directly capturing lightning isn't really feasible, what are some of those alternative paths? What are researchers exploring now?
Well, this is where things get really exciting. Instead of trying to contain lightning itself, we're trying to, copy the processes that make it so powerful. We're like reverse engineering nature.
That's so cool. So what are some of the most promising areas that they're looking into? Because I'm guessing it's not about literal bottles anymore.
You're absolutely right. We're moving beyond the bottle. We're diving into the world of, well, plasma, for instance.
Plasma, huh? Okay, remind me again.
Lightning, at its core, is a massive plasma discharge.
Right, right. Plasma, that fourth state of matter where atoms are stripped of their electrons?
Yeah, it creates this, like, supercharged soup of particles.
It is kind of hard to picture.
I know, but it's the same stuff that makes things like, fluorescent lights glow, or those plasma globes.
Oh, right. Those are pretty cool.
And what makes plasma so fascinating is that it can conduct enormous amounts of energy, and it does it really efficiently.
I see where this is going. So scientists are trying to use this property, this amazing energy conduction of plasma for, well, what exactly?
All sorts of things, but one of the biggest goals is something called fusion energy.
Fusion energy. I feel like that's something I've heard of, but it always seemed like a very distant future kind of thing, very sci-fi.
It does, but it's actually much closer than you might think.
Really? Okay, so fusion energy, how does that connect back to lightning?
Well, to achieve fusion, scientists use these things called tokamaks.
Oh, what the heck?
Yeah, they're essentially experimental fusion reactors. And the conditions inside a tokamak are surprisingly similar to what you'd find in a lightning bolt.
Wow, okay. I'm intrigued. Tell me more about these tokamaks.
Imagine a giant magnetic bottle, right, designed to hold this superheated plasma. And inside that plasma, fusion happens.
So we're not trying to capture lightning anymore, we're learning how to create it in a controlled way.
You got it.
Wow, that's pretty amazing. But how close are we to actually making fusion power a reality? It's always seemed like it's, just around the corner, but never quite here.
It's true. Fusion research has had its ups and downs, but things are changing rapidly.
Oh, how so?
We've seen some really big breakthroughs lately in both material science and plasma physics, and they're bringing us closer than ever to making sustained fusion reactions a reality.
So it's not just a theoretical possibility anymore.
Definitely not. We're seeing a lot of progress in both government-funded research and private companies are getting involved too. There's a lot more investment happening now than ever before.
So there's a real sense of momentum building.
Oh, absolutely. Fusion could be a total game changer. We're talking about a nearly limitless source of clean energy that could provide 10 times the energy of all the fossil fuels on Earth cleanly and safely.
That's incredible. But while we're waiting for these miniature stars to become a reality, are there other ways we can use the principles of lightning? Something a bit more, immediate.
Definitely. While fusion is a long-term goal, there are other areas of research that are already yielding some fascinating results.
Okay, I'm all ears.
One area that's especially intriguing is laser-guided lightning systems.
Laser-guided lightning? What in the world is that?
Essentially, we're talking about using high-powered lasers to create pathways for lightning to follow.
Wait, so we can actually control where lightning strikes?
In a way, yes. Well, the laser beam ionizes the air, creating this sort of conductive channel that attracts the electrical discharge of a lightning bolt.
Okay, that's pretty wild. What can we do with that kind of technology? What are the applications?
The possibilities are huge. For one, we could potentially make harvesting lightning's energy more efficient.
Okay, how?
We could guide it to specific points where we have the equipment to handle that huge surge of electricity. It's like a supercharged, highly precise lightning rod.
I like it. But what about beyond just energy? Any other uses?
Absolutely. Think about redirecting a lightning strike away from a populated area or a critical piece of infrastructure.
Oh, like a power plant or an airport?
Exactly. Laser-guided lightning could offer a whole new level of protection.
Wow, we'd be like real-life lightning benders.
Ah.
But how realistic is all this? Are we actually going to see laser-guided lightning in our lifetime?
It's still early days, but the progress is really exciting. Researchers have already successfully used lasers to guide lightning in controlled environments. The challenge now is figuring out how to scale it up to make it work in the real world.
I bet those lasers take a ton of energy to power. Is that a big obstacle?
It is a challenge, yeah. Right now, the lasers used for these experiments require a lot of energy, which makes the whole process pretty expensive. But laser technology is constantly improving, so hopefully that'll change soon. Maybe we'll see more efficient and powerful systems that could make laser-guided lightning a viable option for both harvesting energy and protecting us from lightning strikes.
This is all incredibly cool, but is there a way to tap into the principles of lightning, without having to shoot lasers into the sky?
There is. And this is where it gets even more interesting, I think.
Okay, tell me more.
Well, remember that the Earth itself is kind of like a giant electrical generator. Its surface is constantly being charged by things like solar radiation and all sorts of atmospheric processes.
Right, creating this huge reservoir of electrons.
Exactly. It's like a natural electrical field that surrounds our whole planet.
It's kind of crazy to think about.
And scientists are working on ways to use this field to generate clean energy.
Wait, so instead of trying to catch lightning from the sky, we could be getting energy from the ground.
Exactly.
How would that even work?
One idea uses something called humidity gradients.
Humidity gradients, I'm not familiar with that.
It just refers to the differences in moisture levels in the air. And surprisingly, those differences can be used to generate electricity.
Seriously.
Researchers are developing devices that can, essentially, harvest static electricity from the atmosphere. It's using the same principle that creates those little static shocks we get sometimes.
Wait a minute, you're telling me that those zaps we get when we touch a doorknob could hold the key to a new energy source? That's wild.
It might sound a bit crazy, but the science behind it is solid. Imagine a world where we have these, invisible power plants silently drawing energy from the air around us. No giant towers, no noisy generators, just clean, renewable energy coming from the atmosphere itself.
Oh, okay, now that's a vision of the future I can get behind. So instead of trying to capture lightning in the traditional sense, we're learning to harness, the essence of electricity itself.
You got it. The whole quest to bottle lightning has really taken us on an incredible journey. We've gone from trying to grab these bolts of raw power to exploring these incredibly complex mechanisms of plasma, atmospheric electricity. It's changed the way we think about energy entirely.
It really is amazing how pursuing one goal can lead us to so many unexpected discoveries.
Exactly. And that's the beauty of science, right? It's not always about reaching the destination you set out for. Sometimes the most valuable discoveries are the ones you find along the way.
This has been such an illuminating conversation. I never would have guessed that something as seemingly simple as a lightning bolt could open up so many possibilities.
It's amazing what we can learn when we start asking questions and pushing the limits of what we know.
Speaking of pushing limits, there's one more area of research from the article that I wanted to touch on. Rocket-triggered lightning experiments.
Ah, yes. Rocket-triggered lightning.
It sounds a bit like mad science, but I have to admit, I'm fascinated.
It does sound a bit crazy, right? But it's actually a really clever way to study lightning up close.
So instead of waiting for lightning to strike, we're creating our own on demand.
Essentially, yes.
How does that even work?
It involves firing these small rockets that trail conductive wires up into thunderclouds. It's like we're enticing the lightning to strike where we want it to.
So we're basically creating our own controlled lightning storms.
That's both terrifying and incredibly cool.
It is pretty wild.
I can see how that would be invaluable for research, but it also sounds pretty dangerous.
It definitely has its risks. But the data we get from these experiments is incredible. It's helping us to understand lightning in more detail than ever before. I bet. And understanding how lightning works must be crucial for protecting ourselves from it. It's like know your enemy, right?
Exactly. And that knowledge has been instrumental in developing better ways to mitigate the risks of lightning, like more effective lightning protection systems for aircraft, spacecraft, and even power grids, making them more resilient to strikes.
It's amazing to think we're not just trying to use lightning's power, but also to understand its complexities, to tame it, in a sense.
Absolutely. And that drive to understand, it goes beyond just practical applications. Lightning research is also pushing the boundaries of our understanding of physics and other scientific fields.
Right. Lightning is a natural lab for studying these high-energy phenomena.
Exactly. It's given us insights into everything from, atmospheric electricity to plasma physics to the behavior of electromagnetic fields.
And it's led to some incredible innovations, like the early warning systems we use to predict storms and those ultra-fast imaging techniques.
It's amazing what we've been able to achieve just by studying lightning. We've even used high-speed cameras to capture those intricate branching patterns of lightning bolts, It shows us how the electrical discharges move through the air. And that knowledge has all sorts of implications, from building better electrical systems to understanding the behavior of plasmas in distant stars.
So lightning is not just a source of energy, and it's not just a force of nature. It's also this incredible tool for scientific discovery.
I like that. It's like a key that unlocks new doors of understanding in all these different fields. Every bolt is like a natural experiment,
A fleeting glimpse into how the universe works.
Exactly. And by studying these events, We're pushing the boundaries of what we know and unlocking all these new possibilities.
It seems like lightning is a gift that keeps on giving, even if we never manage to bottle it in the traditional sense.
I couldn't agree more.
Yeah.
It really shows us how much there is to learn from the natural world. By being curious, by asking questions, and by pushing our understanding, we can unlock so much potential.
Well said. This deep dive into the world of lightning has been absolutely incredible. We've covered so much ground, from the basic science to the ways we're trying to harness its power, and even the broader lessons it teaches us about physics and nature.
It's been an illuminating journey, for sure. I hope our listeners have come away with a newfound appreciation for this incredible phenomenon.
Absolutely. And as we wrap up this episode, we want to leave you with something to think about. If something as powerful and as unpredictable as lightning can lead to so much innovation and discovery, what other wonders of the natural world could hold the key to solving our biggest challenges and creating a brighter future?
Keep asking questions, folks. The universe is full of surprises. The pursuit of knowledge is an adventure that never ends.
I love that. Thanks for joining us on this electrifying deep dive. Until next time, stay curious. Keep those minds sparking.
It is, yeah. Plasma. It's all about plasma.
Plasma. Okay.
Remember how we talked about lightning being this massive plasma discharge?
Oh, right.
Well, scientists are looking at ways to use plasma to create energy.
Okay, so how do we go from lightning to, usable energy?
Well, it all comes down to how incredibly efficient plasma is at conducting energy. I mean, we're talking enormous amounts of energy here.
So how do we tap into that?
One of the most, I guess you could say, ambitious projects is fusion energy.
Fusion energy. Okay.
It's the process that powers the sun and all the stars.
Right. I've heard of fusion, but it always seemed like something out of science fiction.
It kind of does, doesn't it?
So how does it actually connect to lightning?
Well, scientists are trying to create these miniature stars right here on Earth.
Miniature stars. Okay, now I'm really curious.
They're called tokamaks.
Tokamaks.
Yeah. And what they do is they create an environment inside this device that's very similar to what you find in a lightning bolt.
Wow. So instead of trying to catch lightning, we're making it.
Exactly. We're creating it in a way that we can control.
That's incredible. But I have to ask, how close are we really to making fusion power a reality? It feels like we've been hearing about it forever.
It's true. Fusion has had its share of challenges over the years, but we're making real progress now.
Oh, really? What's changed?
There have been some major breakthroughs recently in material science and plasma physics.
And that's helped too.
It's bringing us closer than ever to achieving sustained fusion reactions.
Sustained fusion reactions. So that means...
It means that we could be on the verge of creating a nearly limitless supply of clean energy. I mean, imagine 10 times the energy of all the fossil fuels on Earth, and it's clean, it's safe.
That's pretty mind-blowing. It's hard to even wrap your head around that kind of energy potential.
I know, right? It would be a total game changer for everything. How we power our homes, our transportation, everything.
It's a pretty exciting prospect. But while we're waiting for these mini stars to become a reality, are there any other ways we can use the principles of lightning, in the meantime?
Absolutely.
Okay, what else is out there?
Well, there's this idea of using lasers to guide lightning.
Laser-guided lightning. Okay, you're going to have to explain that one.
So picture this. You use these high-powered lasers to basically create paths in the air for lightning to follow.
So we can actually control where lightning strikes.
In a way, yeah. The laser creates this conductive channel that attracts the lightning.
Wow, that's incredible. What would we use that for?
Well, for one thing, you could potentially make harvesting energy from lightning strikes much more efficient.
Okay, I see how that would work.
But there are other applications too. Think about protecting things from lightning strikes. You could redirect the lightning away from important infrastructure.
Like power lines or airports?
Exactly. Laser-guided lightning could really revolutionize how we protect ourselves from those destructive strikes. It would be like lightning benders.
It does sound pretty futuristic, but is it even possible?
Researchers have already managed to guide lightning strikes using lasers in controlled environments.
So it's not just theoretical.
Not at all. The challenge now is scaling up, figuring out how to make it work in the real world outside the lab.
I can imagine that the lasers used for this kind of thing must be incredibly powerful and probably take a ton of energy to run. Is that a problem?
It is a challenge, yeah. The energy costs are pretty significant right now, which makes it hard to implement on a large scale. But laser technology is advancing rapidly, so hopefully we'll have more efficient, more powerful lasers that can make this a viable option for both harvesting energy and protecting us from lightning strikes.
So there's a lot of potential there, but it's still early days.
Exactly. But in the meantime, there are other ways to explore the energy potential of, well, of the Earth itself.
The Earth itself, what do you mean?
Well, think about it. The Earth is constantly being bombarded with energy from the sun, and it creates this vast electrical field. It's a natural reservoir of energy just waiting to be tapped.
Okay, I'm listening. How do we tap into that?
One idea is to use something called humidity gradients.
Humidity gradients.
It basically refers to the difference in the amount of moisture in the air from one place to another. And you can use that difference, that gradient, to create electricity.
Really?
Yeah, it's the same principle that creates those static shocks you get sometimes.
Wait, you mean those little zaps you get when you touch a doorknob? That's the key to a new energy source?
It might sound crazy, but it's true. Imagine a world where we have these invisible power plants that are silently drawing energy from the air around us. No giant towers or noisy generators, just clean, renewable energy, all thanks to those little static shocks.
That's a really cool vision. So we're not catching lightning in a bottle anymore. We're harnessing the fundamental forces of nature.
That's a great way to put it. The whole quest to bottle lighting has taken us on this incredible journey. We've moved beyond trying to physically capture these bolts, and we're starting to understand the underlying forces at play.
And that's led to some pretty remarkable discoveries and innovations.
Absolutely. And it just goes to show that the most exciting discoveries often happen when we're not even looking for them. Sometimes the journey is just as important as the destination.
I love that. This deep dive into the world of lightning has been so illuminating. I never would have guessed that something like a lightning bolt could teach us so much about the universe.
It's amazing, isn't it? There's so much potential out there, so much to explore.
Speaking of exploring, there's one more thing I wanted to ask about. The article mentions something called rocket-triggered lightning experiments. It sounds kind of intense.
It is pretty wild.
Yeah.
But it's a really ingenious way to study lightning up close.
So how does it work?
Basically, scientists fire these small rockets, trailing wires, right into the heart of a thunderstorm.
So they're basically like provoking a lightning strike.
Exactly. It lets them study lightning up close in a controlled way. It's incredible. They can learn so much about how it behaves.
Yeah, I bet. But how safe is that? Shooting rockets into a thunderstorm?
It definitely has its risks, no doubt. But the information they've gathered has been invaluable.
In what ways?
Well, it's helped us to design better protection systems, for things like aircraft, spacecraft, even power grids.
So we're not just trying to harness lightning, we're also trying to, outsmart it.
You could say that. We're learning how to minimize the risks.
It really is amazing how much we've learned just by studying lightning.
Oh, absolutely. And it's not just about practical applications either. Lightning research has really pushed the boundaries of our understanding of physics.
Right. It's like a natural laboratory for studying these high-energy phenomena.
Exactly. And it's given us insights into all sorts of things, from atmospheric electricity to how electromagnetic fields work.
And it's led to some pretty incredible innovations, like early warning systems for storms and those super high-speed cameras.
Oh, yeah. It's amazing what we can do now. I mean, we can even capture the way lightning branches out, the way it moves through the air.
And that helps us to understand
All sorts of things. How to design more efficient electrical systems, even to understand the behavior of, plasmas in stars.
So lightning is like this key that unlocks all these different areas of science.
It really is. It's a reminder that nature is full of these incredible secrets just waiting to be discovered.
This has been such a fascinating conversation. It really makes you appreciate the power of lightning, but also the power of human curiosity.
Absolutely. It's that drive to understand, to push the boundaries of what we know that leads to these incredible breakthroughs.
Well said. Well, listeners, we've reached the end of our electrifying deep dive into the world of lightning. We've covered a lot of ground today, from the basic science to the innovative ways we're trying to harness its power. But most importantly, we've seen how lightning can teach us so much about the universe around us and inspire us to keep exploring.
It's been a real pleasure, and hopefully you've all come away with a newfound appreciation for the power of lightning and the power of scientific inquiry.
And who knows what amazing discoveries are still out there just waiting for us to unlock them. Until next time, stay curious and keep those minds sparking.